All right, so I'm going to continue on the branch that we started by using my usual development environment, which is not this one. This one is in a folder called delete me. It is this one. And now we can see that our previous commit is already on here. If you go to git status on branch, do a few projectiles, but I would like to git log optimize projectiles for UAA 0v03. That's the commit message we just made. And we're just going to use this branch to add a couple of other projectiles just to see the type of patterns that we can expect, that you can expect when you go through these yourself. All right. So again, just do this, remove that one, make it look slightly better. And there we go. Now let's check what unit uses this. That would be the UAA0310, UAB4, and the UAB. There we go. What? Apparently I'm in a game. Oh, oops. Right. It wasn't test. Alright. So this makes it easier for the reviewer to confirm your changes. In this particular example, we didn't really change anything spectacular, but you know, it's just the idea that matters. Again, this one already did the optimization where we prevent creating a local. Same thing, we can just do the import here. Make it a bit more tidy. And then search for instances of this weapon. There doesn't appear to be. There we go. This one's used by the XAA0202, which is. I started recording. Am I sharing my screen? Yes, I'm sharing my screen. I think this is the combat fighter, the AN combat fighter. All right. Now these are not particularly spectacular, right? So let's move on to one that is a bit more involved. We could, for example, think some of these torpedo. No. Yes, let's look at this one. All right, so let's look at what we have. We have a torpedo ship projectile. We have the AAN torpedo number 2. It has an LOD. Ooh, I totally forgot to check that for the previous ones. This one is apparently not used. This one is though. That's odd. So we have a projectile here that doesn't really see the day of light. Ooh, split up thread. This one does see the day of light. UAB. Okay, so let's look at this one then. UAB 2205, which is start of the game. I just started a map that has no water. Can't test a torpedo on a map with no water. Let's get out of this one again. And let's go to our favorite map. C10 clutch. There you go. And then we want to see torpedo chrono pack. Don't even know what that means. This will split up into 4 chrono torpedoes after it gets close to an enemy. Sure. Okay. So this is the Tech 2. And then we make some frigates. It has sonar. I'm not seeing it. I'm not seeing it split up though. Oh, that's interesting. Apparently they removed it. On enter water. So apparently all of this is not being run. So this is the part, if we look at the original pull request, this is the part where I talk about remove logic if it has no use. This split up thread is no longer called. Therefore, this entire thing can be simplified to, let's see, we've got a splash skill. That's not being used. Is it something else? All right, let's look at the base projectile. Let's close everything. Let's close others. AN projectiles. Affix trail 1. Splash skill starts at 1, I think. Splash skill, where are you? There's no splash skill. Where does this get used then? We have a... That's odd. On water entry emitter projectile. So let's go to default projectiles. Enter water thread. Splash skill. Not used. Not used. I think this is not used. Oh wait, there it is. But this is a different projectile. Here we have a 2. But this is again a different projectile. And these use it, but they're not used in any of the base classes. So I think it's safe to remove this one. Number of child projectile references to these, right? These functions. So we can just get rid of this one. Kill waiting thread. I don't think this is used. No, the only reference. So we can get rid of this one. Kill split up thread. Only reference. We can get rid of this one. Distance before split radio, that is used in this function again, so no use. Velocity on enter water, not used anywhere else outside of this file. And it's used here in code that's commented out and in code that's not reached. So we can definitely remove that one. We can remove all the comments. And then this split up thread is not being called anywhere, right? In the entire hierarchy. So we have aim projectiles, which is this one, and then the on water entry projectile, which is this projectile right here, which inherits from projectile, which is this one right here. None of these use that function, which means that we can remove this one here too. And with that, this projectile is suddenly very simple. Namely, we put this here, put that there, update the description, and there we have it. Question is, does the unit still work? So just to confirm that we have the right unit, on create is function self spec, and here we can do a log I am made. Here we go. And now if we move this unit here, I am made, right? We do have an error here. Unexpected type for army object. All right, because we're not calling the base class. Now just do this. We now know it's the correct projectile. So let's see, does everything still work? And there you go. Everything works just as usual. And now this was actually a bigger performance improvement than we had than you'd expect, because right now the specification is empty, which means that we do not have to create a new class. Instead, we can reuse the class that we have here as a base class. So that means that we didn't just remove some functionality that's not being used, we also prevented one class from being created. So this is pretty decent, right? It's a good change. Now, let's look at this next. Torpedo cluster projectile script for the XAA0306, which is the advanced torpedo bomber. Alright, so what do we have? On create has impacted is false. We create some trail. Got some water effects. Then here we create a whole bunch of child projectiles. And we give these... Okay, this is interesting. So this line here is commented out. So X mul, we can remove this mul call. We can remove X and Z. We can remove CA and SA, and we can remove angle. Right, so we can simplify all of this logic to this. Remove the comment. Number of child projectiles. We are creating one child projectile for every projectile. That seems odd. This is odd. Why are we doing this? So we are creating one child. Oh no, we're creating two of them, because the iteration starts at 0 instead of 1, and this boundary is inclusive. So I think we create two projectiles for each log. Just make the unit. Let's just see. See, so we make two projectiles, a 0 and a 1, which means that when these fellas are entering the water, you can see that there are two spheres. So the bomber probably drops 4 projectiles, and when they enter the water, they turn into 2 different projectiles. You can see them right here in the water. Okay, so we create a bunch of projectiles, we stay underwater, and then we create a vision entity table allocation right here. All right, so this is a nice candidate to look at. Let's see what we have. So we already removed some logic in here because it wasn't being used. Right? I do wonder though, what happens if we do use this? Just out of curiosity. Now they all go to the target and do a massive amount of damage because this is tech free. I think it splits up the projectiles slightly more. Which makes sense because we set the velocity to an angle that it was already roughly at, so. Let's see. Yeah, not very. What if we put this on 30 to 20? Not very impressive. Yeah, okay, so I think what happens is that they track, right? These projectiles track. So even though we give them an offset, they immediately start tracking towards the target. Oh, but now they track really fast. Okay. Anyway, this doesn't really do much. So we're right to just remove this. We're doing a self stay underwater here, but then we destroy ourselves. So we don't have to do this. We don't have to do all these. Let's see, we don't have to do all this computation either, because that was used by the code that was right here. Right, so if we look at the changes that we made, you can see here that the angle initial, angle increment, which is this one, angle variation, which is that one, angle range, which is not, oh, that's used here. So we can get rid of all of this. Then we could just simplify this to say just that, so that we prevent this one. We don't need this call here either, because these were again used by the code that we removed. Right here we see val x and val z, so we don't need this call here either. So now we just have to try it, projectile BP, but we don't need to store that in a local. We can just put that in there. And then here we add a comment saying create 2 child projectiles. All right, so that's nice. So let's look at the rest. Has impacted is false. Does that actually, it's not being used here. Where does that get used? By other scripts that are and torpedo. But this one, see, so all of these script files, they actually use it. If not, but this one doesn't. So we can remove this call. We create a trail. This line here is interesting, right? So we create a trail. We do an engine call here, while we could be doing army, because the army is set during onCreate. And then we import some effect, which we should definitely not do like that. Instead, we should say fx custom trail and then just say self custom trail. So now we create this trail right here. I'm wondering, what is this torpedo cluster? And creates a whole bunch of stuff. A torpedo ship projectile on water entry emitter. Okay. So we can also just say fx trail. All right. So that's some, again, if we look at the pull request, remove logic if it has no use, right? All the logic that we removed so far wasn't really doing anything. But the Lua compiler is not smart enough. It's not an actual compiler, it's an interpreter. It's not smart enough to realize that the information was not being used. For example, initially here, it's not smart enough to know that we are creating all of these locals here and that we end up not really using them. It just literally does what we wrote. So it's going to allocate these locals, do some computations, then do all of this, then not do the part that we commented out, right? It's not going to do that. And then at the end of the function, it's going to clear its stack again, which means that we lose all the information that we computed. So that is what this part here is about. Now we're going to look at this one, up value engine functions. So for example, this create trail, we should definitely just that value Set value scope for performance. We're not really using any other engine functions here. The global context, so we're just gonna leave that at this. Reuse tables as much as possible. So this one's interesting. There are quite a bunch of units that create vision with their projectiles, and so does this one do. On enter water, it creates something that gives me water vision. So if I have some stealth submarines, Cybran Tech 2 submarine killer, then this should become visible. Because there it is, right? So it's now visible. And the reason it's visible, because we create this vision entity with a radius of 30 that has no OMI, no regular vision, but it does have water and sonar vision. That's why we can see the submarine. Because otherwise, if we would now just fly away, right? Right now, we literally have no intel on the submarine because our sonar doesn't get far enough, but we can still see it for about a few more seconds, and then it should disappear. There it is, right? So now it's gone. So that's what it does. And because it's stealthed, we can't see it right now either. But if we would drop the projectiles in the water again, drop them too far. No, this may actually kill him. No. But now we can see it again because there's a radius of 10 and the vision lasts for about seconds. And that's what this part here does. Now there's one mistake here that shows up a bit too often, and that is that for some reason we only call the base class at the end of the function. That's not how this works. You should always call the base class first. But let's see if we can get rid of this table here. So let's look at what this vis marker is. We have a file called vis marker. We have a file called vis marker. There we go. So this is a class. It's not particularly an efficient class. So what does this class do? We create a spec file, right? So that's the specifications of our vision marker. And when we make an instance of the vision marker, then we set the lifetime, radius, army, blah, 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 blah. We do all of that. But that means that we are deep copying our specification here into ourselves. So we're not creating one table with 7 elements. We're creating 2 tables with 9 elements. Right? One table that's 7 elements and another table that's 9 elements. So that's you know, that's pretty hefty. And then when this is just the initialization phase, then we've got the onCreate, and during the onCreate, we warp ourselves. We create another vector which returns a new table with a meta table, and we create somewhere. If we have a lifetime set, which we do, right? We have a lifetime set here. Then we create a thread. And after that, we die again, right? So this is actually a very expensive line, considering that we are launching 4 projectiles, which means that we are making 4 of these tables. We're creating 4 of these classes, and each of those classes creates another 9 entries in themselves and a fork thread. So if we be having 100 of these bombers, then we will be creating 200 relatively large tables and 200 relatively 800 relatively large tables and 400 of these vision markers, which is pretty hefty. Now, because the duration of this video is relatively short, I'm not going into the discussion as to how we can improve this vision marker, but I am going into discussion as to how we can remove the creation, the allocation of this specification table. So what can we do? Well, we know that we are going to need this specification table. We just don't know the information yet. We do know that some information is going to be always the same. For example, the radius, the lifetime, the OMI, and the vision is always set to the same value, which means that we only have to actually set the X, the Z, and the army. So let's do that. Here we have a cached specification table, cache specifications, and instead of creating a new one, we just say local spec is da da da, and then we go spec dot x is pos 1, spec dot z is pos 3, and spec dot army is this army, which is self.army, because we store that, we cache that when we create the projectile. Right, if you look here at the projectile, then you can see here that we cache that army. And now we prevented this table allocation. And in this case, this is a safe operation to do, because the table is used once by the vision marker. There's no YELT, there's no waiting, right? We didn't break this really fancy word. Can't think of it right now. Anyway, we pass the specification into the vision marker, and the vision marker then deep copies the table into its own table, right? Into its own definitions. And because there's a deep copy going on here, we know that we can reuse this table for another projectile that's created at the same frame. So that's a nice performance improvement, not one that's necessarily directly noticeable, but if you would do this for all the projectiles that create vision, then during a battle where these are used, there would be a lot less pressure on the garbage collector to deallocate these tables again. All right. Does everything still work? Yes, we can still see the submarine right there. So this works fine. Then we destroy ourselves. All right. Then on impact, apparently if this original projectile that are flying here through the air, if target entity is this nil and target entity is this air, then return. This is technically not possible. If we have no entity, but the target type is air, then we return. This is not, I don't think this is possible. I think what they're trying to say, if there's an air unit, if we hit an air unit, then we don't do any damage. I think that's what they're trying to say. But if we hit an air unit, then there has to be a target entity. Because there's no flying terrain. The target entity is only nil if we hit the terrain. I'm pretty sure that this is not entirely possible. I'm gonna think about that one, but let's add a comment. Is this possible? And then the reviewer is gonna help you determine whether or not this is possible. And then we do the on impact poll right there. So this is the, let's see what we have. Yeah, so this is one of the optimizations that we can apply to these projectile files. And just to see what we had before, let's do a git diff. Actually, I think there's a better way of doing this. We can go here and then review and explore view, open file history. Let's do, no, oh, that's that, okay. Open file history. Apparently I need to buy stuff for that. Not interested. I should be able to just source control. Yeah, there we go. So here we can see all the changes. We added this cached specifications. We cached some imports, right, that we were doing here. This import that was inline. And import is a global function again, and now it's just always in the meta table that's shared across all the projectiles. Because this is shared across all the projectiles, it's always this trail. And we removed a lot of this logic that was not used in the end. This happens surprisingly often. I'm not really sure why, but you know, it happens. So we removed all these locals, so the stack of this function is a lot smaller. And we prevented this table allocation right here, right? By reusing the same table for every projectile. So that's not bad. But now the 30 minutes are over. So I'm gonna call this a day. So git stage blink, git commit, working on a bunch of projectiles, and then git push to put it on the branch. And now if you go back to GitHub, we can see that our changes that we made are now live here on GitHub. And once we have reached, say, about 10 files or anything between 10 and 20, then we start a new branch, did in the first video, and then continue the progress until we've done all the projectiles. Now, I gotta be honest, I cut some corners. For example, I didn't check the blueprint here, which has a mesh set but no LOD cutoff, which means that I need to go over these files again, because if I look at the original pull request, then that pull request asks us not to just look at the scripts, but also to specifically look at this LOD cutoff value, which is not set here. So I should add LOD of is, say, 120, whatever is suitable for this. I'm not really sure what is suitable for that projectile. You need to check it out and see when the dot, because projectiles become dots at some point, when the dot is essentially over the entire missile, then you know that you're at the point where you don't really need the missile anymore. Git stage, git commit, add LOD, git push. So that's roughly the deal of this pull requests here. Each and every time you can pick up a few of these projectiles. Doing so, you get more experience with Lua, you get more experience in development environment, and hopefully you'll be interested in picking up issues. All in the name of raising the performance of the game that we all play and love here at FAF. With that said, that's the end of this video. In the next video, we're going to look at the AM Quantum something facility. Intelligence facility, and something with AM and Quantum, the XA3310, because that appears to be one of those units that they introduced into Forge Alliance that's not finished. Please make sure to also watch the video that MadMax is going to upload to YouTube on the FAF website. It shows you the modeling process of what he did to add the bones and all the things that were required change-wise surrounding the script that we will be doing in this video.